Hi everyone, today we're gonna use GeoGebra to prove that the sum of the interior angles of any triangle equal 180 degree and to discover the value of the exterior angles. So we're gonna type GeoGebra and click on the link and click on GeoGebra Classic, and in this case I will not need the calculator. I can drag a little bit the drawing to the left side to have more space for myself, and I go to the polygon, click on polygon and choose 3 points ABC. Actually I don't need the label on the segment, so I can right click on the segment and I uncheck show label, C show label, A show label, and with this idea I have the triangle without the label of the segment, but I can keep the label of the vertex. The next step, I can search for the interior angles of this polygon. Actually I can do it in one step by clicking on angle and anywhere in the polygon, and I can make the angle a little bit clear with this way. And if you notice that there is a decimal, to avoid this decimal I go to the main menu and I click on options, rounding, and I click on 0 decimal place. So with this way you're going to see that it doesn't show the decimals. Now I need to find a way to find the sum of the angles of this triangle. So I can go to the input and open bracket, and I start to type the 3 angles, alpha plus beta plus gamma. So I go to this one, I click on this symbol and I choose gamma plus beta plus gamma, and I click enter. As soon as I click enter, you will see in the input that give me 180 degree with a new angle. So in this case I can relate this to the text. So I can create a text here by saying the sum of the interior angles of triangle. I can go to the advanced and I can choose this symbol to find the symbol of triangle, and I continue to triangle ABC equal. Now I need to relate the angles to the equation, so I go to this icon and I choose alpha plus beta plus gamma. So alpha plus beta plus gamma, and I can add also the sum, which is this one, and click OK. You will notice here it's gonna bring 60 plus 38 plus 82, and it's gonna show us that it's 180. So the student, if they want to check if I change the position of any vertex, it's gonna keep the 180, yes. So you can see it changed the value of the angles for sure. However, it keep the sum with the same way. Now, what about the exterior angle? In this case, we can create a line on AB, and I can create a point on this line to have the angle 6BD, which is the exterior angle of this triangle. And actually, to get the value, I click on angle and click on DBC to get this value. So you can ask the student, what do you notice about this exterior angle? You let them think a little bit until they discover that the total of these two angles A and C equal to 146. 2 plus 4 equals 6, 9 plus 5 equals 14. So that means the exterior angle equal to the sum of the other two angles that it's not adjacent to this exterior angle. Color, the opacity is here, change it to red for example, and it's going to be clear that the exterior angle is 146. Now if I change this angle, it's going to have the sum for sure by creating the text again. So I can say what? I need to check the exterior angle, and you can see the exterior angle here has a name CBD equal to the sum of the other. So you can see in this case it's gonna bring the alpha plus, in this case, gamma equal to this symbol, which is like the E. Okay, so the exterior angle CBD equal 54 from here, plus 92 from here, equal 146. Now to ask the student to change some angles, you see that the change happened. 65 and 81 equal 146, the exterior angle, and again it keep the sum of the interior angles as 180. So with this way, whenever or with any change, it can affect this angle, but it's not going to affect the 180, and the total of these two angles is always equal to the exterior angle of the triangle. So I hope this short session it make it clear how to prove that the sum of the interior angles of any triangle equal 180 degree, and that the value of the exterior angle equal the sum of the two angles that they are not adjacent with the exterior angle. Thank you.